All right, let's working on the next example. So next example, if we look at the equation, we have variable x on denominator. Remember earlier we see a slide saying listing all the restrictions of the domain of the variable, right? So this is the case. Because x is on denominator, and then we know denominator cannot be 0, otherwise the whole expression will be undefined. So first thing we need to know, right? X cannot equals positive 1. If x equals positive 1, 1 minus 1, that will equal 0. So denominator equal to 0, this whole equation will be undefined. Okay, so we just can't do that. That's why we have to listing the restrictions. X cannot equals 1. And a similar idea as what we did with the previous example, whenever we see a denominator in the equation, okay, we would like to cancel the denominator. Okay, so we want to cancel x minus 1. How can we cancel x minus 1? We can apply multiplication principle, right? Both sides of equation multiply by x minus 1. So let's do that. We multiply x minus 1 and then times, I just rewrite left hand side of the equation and then right hand side of the equation, right? So if you want to write it clear, you can just write x minus 1 over 1. So you can see that is on numerator, right? But anything over 1, you don't have to write. I just trying to show you, diagonal, you can cancel that out. All right, so next step, we need to simplify, right? Left hand side, we have 2 terms, so every term need to multiply by x minus 1. So x minus 1 times 3x over x minus 1, that's the first term on the left hand side, and then plus x minus 1 over 1 times 2, right? Times 2. 2, you can write it 2 over 1, but you don't have to, if you really understand 2 is on numerator. Right hand side, we can simply cancel the diagonal, right? Numerator, denominator, they're identical factors, so we can cancel out. So right hand side, we only got a 3 over 1, which is 3. And the left hand side, we further simplify, x minus 1 cancel, so just 3x, right? And then plus 2 times x minus 1 in the parentheses equals 3. And then further eliminate parentheses, 3x plus 2x minus 2 equals 3. Combine like terms, right? These two combine, 3x plus 2x. I don't have space, I write on the top, so that's 5x minus 2 equals 3. And then both sides add a 2, so I got a 5x on the left, and a 3 plus 2, that's equals 5 on the right. And then multiplication principle, both sides divided by 5, and then I solve x equals 1. So should we conclude x equals 1 is the solution? Okay, question. Should we do that? Remember what we did at the very beginning. When we start solving this equation, we listing the restrictions, right? X cannot equals positive 1. But when we solve this equation, we do get a conflict statement. We solve x equals positive 1. So what will be the solution? We got x equal to 1, but x cannot equals 1. So the solution is, for this particular linear equation, there is no solution. Okay, that's perfectly fine, when there's no solution for a particular equation. Okay, that's quite normal. Sometimes you'll find one solution, sometimes you'll find many solutions, sometimes you'll find no solution. Okay? So this is the example, we mentioned earlier. You have to listing all the restrictions first. Otherwise, you will be very easy to draw the conclusion solution for this linear equation is x equals 1. But that is not true, right? Because x equals 1 will make the whole equation undefined. So x cannot equals 1. And then due to this conflict, we just draw the final conclusion. For this particular linear equation, there's no solution. So mathematically, how to represent no solution? We can use set notation, like empty sets. That's represent no solution. Okay, like that. Solution set is empty. It's like a Greek letter phi. Okay, that's what this symbol called. That's represent the empty set. The last example, solving problems that can be modeled by linear equation. So when we apply the solving linear equation skills to solving applied problem, there are general 5 steps. Okay, so you can read through it. I just, kind of emphasize the key. The first step, you need to identify the unknown quantity, or in other words, what you're looking for, what you're trying to solve. Okay, that's the first step. So you need to read through the problem, okay, and then pay attention to the question being asked. Normally that will be the, at the end of the problem, right? The last sentence is the question mark. That is where you need to identify what you're looking for. And then second step, you need to assign variable. Okay, assign variable. Assign variable for what? To represent the unknown quantity, which is what you're looking for. Okay, that's the second step. The third step, you need to make a list of all the known condition or known facts, and then try to translate them into mathematical expression in order to set up equation. Okay, that's the step 3. We also call that build up your mathematical model. Okay, we call that equation called a model. And then next step, solve the equation, and then finally check the answer. Okay, that's the general 5 steps when you're trying to solving applied problem, which is the word problem. All right, let's look at example. There's a total of 18,000 is invested, some in stocks and some in bonds. That's the first sentence. Okay? And then if the amount invested in bonds is half that invested in stocks, and ask you how much is invested in each category. So this is the question, right? That's what we're looking for. So what we're looking for exactly? In this particular problem, there's 2 unknown quantity, right? We need to know how much, okay? How much money invested in stock, and then how much money invested in bonds, right? So we have 2 unknown quantity. So first step, we identify what we're looking for. And the second step, we need to assign the variable, right? So we have 2 unknown quantity. You need to assign variable x into either quantity. Doesn't matter really which one you assigned x, which one, you use X to represent it. So let me just let X represent the amount of money invested in stocks. So how to represent the number of money buying the bonds? Can we figure that out? The total money invested is 18,000 and X dollar buying stocks. So the rest will be buying the bonds. Does that make sense to you? So that's 18,000 subtract X. That's the amount of money buying bonds. Right? That's the second step, assign variable. Okay, if we have two unknown, you only let one assign variable X, the other one use expression, okay, to represent it in terms of X. So step 3, we need to identify our model, right? Trying to set up equation. So how to set it up? Let's reread this sentence and see how you understand it. If the amount invested in bonds is half that invested in stock, right? So is, that means equal sign. What are equal? It says the amount invested in bonds. What is the money invested in bonds? We already have the expression. So the money invested in bonds, that's 18,000 minus X, is half invested in stocks. So what's half means to you? Half is the 1/2, right? 1/2 of the stock. So what is the stock? We use X to represent the how much money invests the stock, right? So by translating this sentence, okay, from here to here, I set up the equation like that. Think about that for a minute, see whether that makes sense to you. The amount of the money invested in bonds, okay, which is here, is half of the money invested in the stock, okay? And then step 4, we're solving this equation. We have two variable terms, right? Negative X and then positive 1X. They're located on both sides of equation, so we need to move X to the other side. Both sides add X. So we got 18,000 equals 1 plus 1.5, right? That's 1.5X, right? Or you can write as 3/2, right? 18,000 equals 3/2X. And then both sides times 2/3, right? That's how we cancel coefficient. So these two cancel, we have X, and then 18,000 divided by 3, that's 6,000. 6,000 times 2, that's 12,000. So X, that's represent the amount of money invested in stock, and then how much invested in the bonds, 18,000 minus 12,000, that will equals 6,000, right? And then we can answer the question. Invest $12,000 buying the stocks, and then invest $6,000 buying the bonds, and then the amount of money buying bonds, that's 1/2 of the money buying stock, right? That's exactly what we got. All right, so next slide is showing the details step by step. It's pretty much the same as what I just showed you. All right, that's chapter 1, section 1.